गाइस सो वेलकम बैक माय चैनल पे मेरा नाम सागर। आज हम इस यूनिट पे देखने वाले थर्ड यूनिट ऑफ डीप लर्निंग का। जैसे हम फर्स्ट यूनिट सेकंड यूनिट हमने इसका वीडियो बनाया और प्ले लिस्ट में डाल दिया। गाइस आपको समझ में मतलब और समझना है और लेक्चर्स को पढ़ना है तो आप हमारे प्ले लिस्ट में जाके उस वीडियो को देख सकते हो और अच्छी तरीके से उसकी प्रिपरेशन करके एग्जाम में अच्छे मार्क्स ला सकते हो, अच्छे प्रिपेयर करके पढ़ाई कर सकते हो, राइट। तो ठीक है, हमने आज इतना कुछ आपको बताया है कि हमें जरूरत अच्छे मतलब क्वेश्चन को निकाल कर उसको प्रिपरेशन करके आपके एग्जाम्स में अच्छे मार्क्स ला पाए। इस क्वेश्चंस को हमने निकाले हैं और इसको इजीली आप अंडरस्टैंडिंग कर सकते हो, राइट। लेट्स टू स्टार्ट टू कंटिन्यू वाचिंग द वीडियोस एंड लेट्स टू स्टार्ट नाउ। ओके, तो स्टार्ट करते हैं। अब ज्यादा देर ना करते हुए इस वीडियो को हम स्टार्ट करते हैं। तो डिफाइन अ फोन कॉन्वोल्यूशन कर्नल पेडिंग स्टैट एंड पुलिंग, ये वर्ड्स आपने कई बार सुना होगा डीप लर्निंग मेथड पे या फिर आपने ऑपरेटिंग सिस्टम पे या कहीं ना कहीं वर्ड्स को कई बार आपने अपने रिमाइंड किया होगा माइंड्स पे, ठीक है। तो उसी टॉपिक पे पढ़ने होते हैं कॉन्वोल्यूशंस क्या होता है, कॉन्वोल्यूशंस क्या होता है और इसका कैसा वर्किंग है ये देखने वाले हैं। In a convolution neural network, several important terms are used to describe how images are processed and feature extracted. This concept help in understanding how CN work efficiently with image data. ठीक है. Convolution is the score of operations CN where a small matrix called a filter is applied to an image extract important features such as age, textures, patterns. These operations scan the image and produce a new output called a feature map, which highlights a specific character of the image. और सेवरल कॉलम नेटवर्क न्यूरल नेटवर्क है। सेम इंपॉर्टेंट यूज टू डिस्क्राइब हाउ इमेज प्रोसीड फीचर एक्सट्रैक्टेड, मतलब कैसे इमेज प्रोसीड हो फीचर एक्सट्रैक्टेड हो। दिस कंसेप्ट हेल्प इन अंडरस्टैंडिंग हाउ सीएन वर्क इफिशिएंटली विद इमेज डेटा के साथ, ठीक है। कन्विंस द कोर ऑफ ऑपरेशन सीएन वेयर स्मॉल मैट्रिक्स कॉल्ड फिल्टर अप्लाई टू इमेज एक्सट्रैक्ट इंपॉर्टेंट फीचर इन डिग्री टेक्सचर पैटर्न। This operation scan the image and produce a new output called a feature map, which highlights specific characteristics of the image. A kernel, also known as filter, is small matrix of value that is used during convolution. Each kernel is designed to detect a particular feature. For example, one kernel may detect horizontal edge, while another may detect a vertical edge. This kernel is slide across the image and pattern, perform a calculation to realize feature map. ठीक है. Padding is a technique used to add extra pixel around the border of image. Padding का technique है जो around extra pixel around करते हैं border images find होता है. This is done to control the size of the output and ensure the important edge. Importance is not lost during convolution. Without padding, the output image becomes smaller. मतलब without padding, so the output image becomes smaller दिखता है after convolution operation से, ठीक है. A slider refer to the number of steps the kernel by views while scanning the images. A smaller stride means the kernel mode, the pixel at time. Capturing more detailed information, a larger stride reduce the size of the outputs and decrease the computation cost, but may lose some details. Pooling is a down-sampling operation used to reduce the size of features map while presenting the important information. It helps in reducing computation complexity and prevent overfitting. Common type include max pooling and average pooling. ठीक है. इनपुट क्या हो गया, कॉन्वोल्यूशन लेयर हो गया, फीचर मैप हो गया, फुल फीचर मैप्स हो गया, पूलिंग लेयर हो गई, फीचर मैप्स, कॉन्वोल्यूशन लेयर, फुल फीचर मैप्स एंड पूलिंग लेयर, फुली कनेक्टेड एंड ऑट। क्योंकि इनपुट इमेजेस 941 जैसे कि हमारा आउटपुट हो गया। जैसे कि हाँ, इस डायग्राम के थ्रू बहुत अच्छी तरह समझ पाएंगे। इनपुट इमेजेस हमारे इनपुट हुआ है और हमारा फिल्टर रेशन बीच में डेटा आया है और आउटपुट रे से जो कैलकुलेशन होकर हमारा आउटपुट डेटा यहाँ पे आई है। तो इस तरीके से हमारा कुछ होता है गाइस। तो आप समझ सकते हो मैक्स पूलिंग हो गया, एवरेज पूलिंग्स एंड नंबर ऑफ पूलिंग्स एंड दिस पूलिंग, राइट। और दिस कंपोनेंट वर्क टुगेदर टू एनेबल सीएनएस टू एफिशिएंटली प्रोसेस इमेज एंड एक्सट्रैक्ट मेनी फीचर्स। थोड़ा कंसेप्ट इस तरीके से आप समझ सकते हो। मैं फिर से रिवाइज कर देता हूँ। डायग्राम देख लीजिए, ठीक है। और हाँ, अब मैक्स पूलिंग का एवरेज पूलिंग आप देखते हैं कंसेप्ट को। एक्सप्लेनेशन कॉन्वोल्यूशन ऑपरेशन, कॉन्वोल्यूशन ऑपरेशन इन CNS NN. The convolution operation is a fundamental building block of convolutional neural network. Fundamental building block है convolutional neural network का. It is extract features from input image by applying filter that highlight important patterns instead of processing the entire image at once. Convolution focus on small region, making it efficient and effective. In the process of filter, kernel is placed on a small region of the output image, input image. The value of the filter are multiplied with the corresponding pixel. Value of the image and result are summed to produce single output value. The filter then moves across the image, repeating the process to create a feature map. Each filter designed to detect a specific feature. For example, one filter may detect edges, while another may detect feature or shapes. As multiple filters apply, the network learn different aspects of the images. The output feature map represents the presence of specific feature in different regions of the images. This allows the network to focus on important patterns rather than processing raw pixel value. Convolution is highly efficient because it reduces the number of parameters compared to fully connected layers. It also preserves a special relationship between a pixel which is agency for image understanding. This makes the CNN very powerful for task rich in images, classification, object detection, and facial recognitions. Output feature map size cap when applying convolution is here. The size of the output feature map depend on a factor such as input size, filter size, style, and padding. This parameter determine how the filter move across the image and how much information it has. If no padding is used, the output size becomes smaller because the filter cannot be applied at the edge of the image. The result stores boundary information when padding is added. Extra pixels are introduced around the image, allowing the filter to cover all region and maintain the original size. Shaders, if the output size small shader produces a larger output because the filter moves slowly and capture more detail. A larger shader result in a smaller output because the filters keep position, reducing the number of computations. Understanding how this parameter affect the output size is important in designing CNS aspect. It helps in controlling the level of details capture and managing computational complexity. ठीक है, ये हमारा हो गया. अब इम्पैक्ट पैडिंग एंड स्टैट क्या होता है अभी हम देख लेते हैं. Padding and stat are important hyperparametric CNNs that directly influence feature extraction, output size, component efficiency. Their proper selection is crucial for designing effective models. Padding helps in preserving a spatial information by adding an extra pixel around the image. Without padding, an important feature near the edge may be lost after convolution. Padding instead at the output to retain the more information and allowing the diffuse network to be built without reducing the image size too quickly. Stride क्या होता है determine how much the filter move at each step. A small stride capture finds the detail but increase computational cost. A large stride reduces computational but may miss important feature. Therefore, there is trade-off between accuracy and efficiency. Together paddings and stride controls the resolution of features, map, and the depth of the information stack. For proper tuning of this parameter help in achieving better performance while maintaining the computational efficiency. Explaining a pooling technique. Pooling is a technique used in a CNS to reduce the size of features map while retaining important information. Its help is in reducing the computational cost and preventing overfitting by simplifying the representation of features. Max pooling selected the maximum value from small regions of the feature map. This helps in capturing the most important feature in that region. It is widely used because it preserves strong features such as and textures. Average pooling, on the other hand, calculates the average value of regions. This provides a smoother representation but may reduce the strength and offer important features. ठीक है. Pooling layer and maximum pooling. 2 into 2 pooling straight 2. Max pooling, average pooling. 4 into 4 is 4 and pools. ज़्यादा से ज़्यादा pooling हो गया pool and up to 4 on sampling. और यहाँ पे अपना डायग्राम दिया है feature map, kernel, convex pools. Pooling reduce the size of feature map, makes the network more efficient and less prone to overfitting, also make the model more robust. Small variation in the input size. Explain the inscription architecture is really important. The inscription architecture is a special type of convolution neural network होता है designed to improve performance while keeping computational cost efficiency and traditional CNN use single type of filter addition layers. But inscriptions network are used multiple filter use of different sizes in parallel. This allows the network to capture features and different scale simultaneously. In an inception model, the input is processed through the multiple paths, such as small filter for finer detail and larger filter for broader patterns. These output are the combined to form a richer representation of the images. Additionally, the architecture uses small filters before a larger one to reduce the computation, which make it more efficient. Inceptions via Google Net. Google Net. Okay. This is a filter concatenations. 1 into 1 convolution, 3 into 3 convolutions, 5 into 5 convolutions, 1 into 1 convolution, 3 into max polys, and 1 into 1 convolution, 1 into 1 convolution, previous layer. Okay, this and the filter connect, start to be, 3 into 3, sticks, strive, sticks, previous layer. The main advantage of the inspection architecture is that it improves accuracy without a significant increase in computational cost. It is widely used in image classification tasks and it achieves excellent performance in a large scale dataset. What is a transform learning? Transform learning is the techniques in a deep learning where a model trained on one task is reused for another related task. Instead of training a model from scratch, which requires large amount of data and time, pre-trained model is used as a starting point. In this approach, a model that has already learned feature from a large dataset is adapted to a new problem. For example, a scene trained on large images dataset can be used for medical imaging tasks. There are layers of the network which capture basic features like age, textures, reviews, while the later layer are modified to suit in the new task. Transfer learning is very useful when the available the dataset is small. It reduces training time and improves performance because the model already the learn useful feature. It's widely used in applications such as images classifications, object detection, and speech recognition. It's different between a features extraction and fine tuning. Okay, let's do feature extraction and fine tuning are two approaches using a transform learning and two difference in which how the pre-trained model is modified. In feature extraction क्या होता है? This pre-trained model is used. It is an and only the final layer is replaced with suited the new task. The earlier layer are kept fixed because they already contain useful features. This approach is simple and work well when the new dataset is small or similar to the original dataset. Fine tuning: some or all the layers of the pre-trained model are allowed to update it during the training. This allows the model to adapt more closely to the new task. Fine-tuning is more flexible and can provide a better performance, especially when the new dataset large or a significant difference from the original one. Feature extractions. Feature extraction is the feature extractions require less computations, while fine-tuning provide a better accuracy at the cost of more training time. The choice between the two will depend on the size and nature of the dataset. Applications of CNS Application of CNN images classifications and object detection. CNS are widely used image classification and object detection, but these two tasks have a different goals and they are widely used in image classification object detection, but these two tasks have a different goal and working approach. In image classification, the goals to assign a label to an entire the image. The network process the image and predict the most likely categories and identify whether image contains cat, dog, or cat. In object detections, the goals Internal goal is more complex. The model not only identify object but also locate with them within the image by drawing bounding boxes. This will require both classification and localization, making it more challenging task. CNNs are highly effective for both tasks because they can automatically learn spatial features from images. In a real world application, images classification used to area such as medical diagnosis, content filtering, while object detection used in autonomous vehicle surveillance system and or however, this application also faces challenges such as the variation, lightning operations, occlusion, and complex background design. Proposed the CNN models in addition to handle these challenges effectively. Designs Design a CNN-based face recognition system. Designing a CNN-based face recognition system involves several important steps to ensure accurate and efficient performance. This first step in reflecting an appropriate model. A pre-trained CNN model such as one trained on large scale dataset is often used as a starting point. They allow the system to benefit from previously learned features. Transfer learning is applied to adapt the model to the specific face recognition task. The final layer of the network are modified to classify or identify face based on the given dataset. Feature extraction techniques are used to capture unique facial characteristics such as shape, texture, and landmarks. The train strategy involves using a well-labeled dataset, face images, applying the data augmentation to increase the diversity, and using techniques such as dropout to prevent overfitting. The model is trained using appropriate optimizers and loss function to improve accuracy. For evaluations, Correlation metrics such as an accuracy, precision, and recall are used to measure performance. Real-world system additional technique such as phase alignment and normalization applied to improve result. A well-designed CNN-based face recognized system is capable of accurately identifying individual when even under different lighting conditions, angles, and expression widely used in applications such as security system, attendance system, and mobile authentications. Right. This is the concept now the completed, and I hope you will be understanding on the concept and easily understanding to all answer easily provided. You getting the good marks and in your exams. So thank you so much for watching the videos. I you again next time meet you another video of a 4 unit in a deep learning. This is concept is easily and to explain. I think understanding. Okay.